Rocket science is a multidisciplinary field that involves physics, engineering, and aerodynamics. It primarily focuses on designing and launching rockets for space explorations, military applications, and satellite development. The key principle behind rocket science is including Newton's third law, thrust, propulsion mechanisms, cooling methods, and failure preventions. When talking about Newton's third law, it states that for every action there is an equal and opposite reaction. This principle is the foundation of rocket propulsion. When hot gases are expanded at high speed from rocket's engine, they push the rocket forward in the opposite direction, allowing it to lift off and travel through space. There are several methods that are used to prevent overheating and failure, such as regenerative cooling, ablative cooling, and lastly, my favorite, film cooling, which injects a thin layer of, often they use fuel, along in the engine's side walls to create preventer thermal barrier. Diving deep into rocket science, there are two main types of rockets that are solid fuel rockets and liquid fueled rockets. Solid fuel method uses fuel and oxidizer mixed into a solid form. There are many advantages for this method, such as simple design and fewer moving parts. It can be stored for long periods of time, and finally, instant ignition and high thrust. Talking about the disadvantages, first of all, once it's ignited, they cannot shut down. Secondly, less efficient than liquid fuel rockets. For example, the boosters used on NASA's space shuttle and many military missiles. When talking about liquid fuel rockets, they use a mixture of oxidizer and fuel, but in a liquid form. This method gives a control over the thrust, and it's more efficient and flexible. However, the disadvantages of this is complex systems, and it requires careful handling and storage. That's it for today. See you in the next video.